Okay, previous lesson we were looking at the tangent ratio. We got a couple more showing up today. We're going to have sine and cosine. Now with the tangent ratio, we almost worked with the two legs. With sine and cosine, we also have to work with the hypotenuse. So again, our focus for the introduction here is we'll be looking at angle A. And if we choose to study angle A, we have to go all the way across to find the leg that's opposite. And then the leg that's next to angle A will be the adjacent. Sine is abbreviated SIN. Cosine abbreviated COS. And whenever I want to find the sine of an angle, I always use opposite over hypotenuse. If I want to find the cosine of an angle, the ratio will be adjacent over hypotenuse. That's why sine and cosine get introduced on the same lesson, because they're both using the hypotenuse. But sine uses opposite, cosine uses adjacent. Okay, so let's look at some examples that actually have numbers. Okay, there are 4 ratios to find here. Well, let's start with sine of S. Notice I don't say sin S, I say sine S, right? I'm looking for this sine of angle S. Well, if I'm at S, it looks like opposite is 63, and then the hypotenuse is 65. Right? Sine is always opposite over hypotenuse. 63 over 65. That fraction will not reduce, but we can convert to a decimal equivalent by doing 63 divided by 65 with a calculator. Sine of angle R. Now the opposite leg is 16. The hypotenuse is still 65. Right? The hypotenuse does not change. Opposite and adjacent change depending on which angle I'm looking at. When I was looking at angle S, opposite was 63. When I was looking at angle R, opposite was 16. Cosine of angle S. Cosine is always adjacent compared to hypotenuse. So if I'm at angle S, the adjacent leg is 16. Hypotenuse, of course, has to be 65. That will never change. Using a calculator, I can convert to a decimal equivalent. Cosine of angle R. Well, if I'm at R, the adjacent leg is now 63. Hypotenuse, of course, is 65. And I get an answer of 63 over 65. And of course, if I want a decimal equivalent, I can do 63 divided by 65 and get a decimal. Direction said around the 4 places. That's rounded the 4 places. Notice something? Cosine of angle S has the same answer as cosine of angle R. Cosine of angle S has the same answer as sine of angle R. We'll talk a little bit more about that in the next lesson. That's not a coincidence, that's something that's going to happen. But again, we'll talk about that next lesson in more detail. Hey, let's find the values of x and y. Well, if I'm at 26 degrees, x is the opposite leg. So I'll use sine because sine is opposite over hypotenuse. So sine of 26 degrees will be x divided by 14. Let's isolate the variable, multiply each side by 14. Again, you're going to have to use a calculator. And then again, notice that I made sure my calculator was set for degrees. Direction said nearest tenth, so that's only one decimal place. So x is about 6.1. We gotta find y now. Keep the picture there. For y, well, since y is the adjacent leg, I'll use cosine, because cosine is adjacent over hypotenuse. So substitute some values. The adjacent leg is y, the hypotenuse is 14. Multiply both sides by 14. Use the calculator. Again, once you get it set for degrees, you can just leave it alone, it'll stay there. But for your initial setting, got to make sure you're in degrees. Y is about 12.6. Find the sine and cosine of a 45-degree angle. I don't even know where to start. Well, I know what to do first. Got to paint a picture. That picture's not going to help. Let's draw a triangle instead. Well, I have to use a right triangle. And I know one angle is 45 degrees. I guess the other angle has to be 45 degrees. Oh. Hey. Remember that lesson on our special right triangles? There it is. You know what numbers we have to use, don't you? The legs have to match, so if I put 1 on one of the legs, I have to use 1 for the other leg. And of course, using the Pythagorean theorem, we can quickly deduce that the hypotenuse has to be square root of 2. Right, this is one of our special right triangles. The 45-45-90 and the 30-60-90 are the two triangles that we should have memorized. Doesn't matter which 45-degree angle I stand in. I can pick either one. The opposite side is going to be 1. The hypotenuse is going to be root 2. Oh. Can't leave a radical denominator. Let's brush off our algebra skills. We can multiply by the number 1 and not change the value, but we will disguise the number 1 as square root of 2 over square root of 2. So in the numerator, 1 times square root of 2 is square root of 2. Denominator, square root of 2 times square root of 2 is square root of 4. And of course, the square root of 4 is just 2. So there's our answer. The sine of 45 degrees is equal to root 2 over 2. That's an exact value. Mathematicians love exact value. If we were in a physics class, we'd probably be asked to grab a calculator and convert to a decimal. Now, of course, when I'm working with cosine of 45 degrees, The adjacent leg is 1. The hypotenuse is still root 2, and we're going to get the same answer. Right? Because on a 45, 45, 90 triangle, the legs match. Interesting. The sine of 45 degrees has the same value as the cosine of 45 degrees. Now, before you start thinking that your brain is full, you're like, wait a minute, how do I remember which ratio for which function? SOHCAHTOA. Right? SOHCAHTOA. The so reminds me that sine is opposite over hypotenuse. Ka helps me remember that cosine is adjacent over hypotenuse. Toa reminds me that tangent is opposite over adjacent. SOHCAHTOA. We are finally ready to dive into IXL. They have a lesson that has the trigonometric ratios for sine, cosine, and tangent.